Hello, everyone. Yeah, so my name is Daniel. I work with GWT on the Google Wave client in Sydney. So today I'd like to share with you some of the best practices we've found have served us well over time with respect to writing reliable, testable GWT applications. It used to be that it was hard for us to write good unit tests, but by applying some of the ideas I'm going to show you, we were able to bring much of our code under test so that when bugs are fixed, they stayed fixed. All right, so just before I begin, I've been asked to point out this link here to this talk's Wave, where you can ask questions and see notes being taken. All right, so what did I mean when I said good unit tests? Well, we can probably agree that these are some properties of good unit tests. Obviously, we want them to run fast, we want to have good code coverage, and we want to have both testing granular code at a granular level, but also at an integration level. At Google, we have this little convention where you've probably heard about it before. We have small tests, medium tests, and large tests. Small tests are ones that run in milliseconds and have no external, they don't depend on network resources or anything like that. And we try to have a rule of about 70-20-10, where 70% of our tests are small tests, 20 are medium, and 10% are large tests. And a large test, or a good test case, would count as a large test. So we want most of our tests not to actually be those. All right, so unfortunately, so testable code simplifies writing such good tests. Now, unfortunately, good applications face some inherent difficulties in the way of achieving this. I'll go through some of them. First and most importantly is JSNI code. Does everyone know what JSNI is? Just in case, I'll quickly explain. JSNI stands for JavaScript Native Interface. It is JavaScript code which comprises the lowest building blocks upon which good apps are ultimately based. It is a necessary bridge for interacting with the DOM and other browser features. Obviously, to run code that calls into JSNI requires having either a browser or some kind of browser emulator, and Good Test Case provides this facility. So any code that we want to test that transitively depends on the execution of some JSNI requires subclassing Good Test Case. Unfortunately, this means that this implies most of the GWT widget and DOM library and any application-specific low-level code would need GWT Test Case. So the problem with GWT Test Case, you guys probably know, is it's slow and cumbersome to use. Ultimately, for realistic integration-level testing, GWT Test Case and Selenium or WebDriver-based testing is necessary. But to iterate quickly and easily achieve high code coverage, we need to be able to put as much of our code under plain old-fashioned, just lightweight JUnit testing as possible. Okay, so the next problem is the need to simulate user interactions. This is further hampered by cross-browser event behavior differences, and I'll talk about that particular point in a bit of depth later. But for example, the differences between key down, key press, mouse down, click, and so forth can be quite insidious between browsers. So some information, the next point, some information needed by our programs can only be properly obtained from a real browser. For example, if we're asking the DOM about its size, like how big it actually ended up being rendered. And frequently, there are tricky optimizations that we need to perform that are specific to the web environment. For example, widget reuse, or data structures optimized for the browser environment, or even on a per-browser basis. Often, we need to defer execution. So for example, by using deferred command or timer, in order to allow layout to be performed further, before further action, or to split up a long-running task so it doesn't block the UI, and other such reasons. Okay, so all of these things can be at odds with testing. So writing web applications is a naturally test-hostile environment. And now that we've got these problems at the front of my mind, I'd like to go into some patterns and ideas that we found helpful in our experience over time. The first thing I'd like to talk about is the MVP pattern. MVP stands for Model View Presenter. Now, if you were here last year, you may remember Ray Ryan's talk about good application architecture that discussed, among other things, the use of MVP in building the AdWords front end. It's a great talk. I encourage you all to check it out. It's on YouTube. What I'm going to outline here might have a few subtle differences, but the gist is basically the same. Okay, so I like to use this little diagram to help explain MVP. It represents the conceptual flow of a UI application. Whether or not it's explicitly stored, a GUI application has at all times some kind of presentation state. And what you see displayed in the UI is a function of that state. So there is some logic, which is at the top here, that I'm conceptually mapping at the top here, that maps the state to the display. And in many cases, if we're just hacking something up, the display and the state will just be conflated together without any distinction. On the other side of the loop, the user actions trigger code that update the presentation state. Now in GWT, it's the display code over here that is the hard-to-test code. It's the code where, with most of our widgets and JSNI and on-browser event handlers of JSO events and so forth. And what MVP is particularly good at is isolating that hard-to-test code to the greatest extent possible, and while still trying to be a lightweight pattern. So in MVP, we have a view and we have a presenter. And the idea is basically put all the complicated stuff in here, all the logic in here, and leave this to be as simple as possible, the part that actually we can't test very well. So it's, so the presenter can then communicate to this view through a very dumb, easily implementable interface. All right, so the goal we're trying to achieve here is that our JSNI-dependent display code is kept minimal and trivial and ideally correct by construction, while all our logic is in testable presenters. Presenters know nothing of their view implementations, as the views are dependency injected into the presenters. Contrast this with MVC, where roughly speaking, I'm sure someone might find a subtle error in this, but basically the thing called the view combines the whole rendering logic and display together. So here, rather than logic pushing updates to a simple view interface, the whole view pulls what it needs from the presentation or model. And we have a controller down the bottom that handles UI events in a similar fashion. Okay, so here is, just to sort of put this a different way maybe, here is an example of an MVP type hierarchy for a foo UI component. We have a foo presenter and a foo view interface. And the presenter knows only of and talks only through the view interface. It doesn't know anything about what specific implementation is backing it. In turn, it receives UI gesture events as a listener of its view and deals with them. So let's start with a particularly trivial example for illustrative purposes, an image thumbnail widget. The capabilities of this widget are quite simple. It can display an image and a caption, and it accepts clicking as an actionable UI gesture. So pretty much all we need in our view interface is exactly that. 2 push methods to set the URL and the caption, and a simple listener interface that provides all the click events. An application can choose to do all kinds of complicated things with this simple building block, but our application logic is shielded from the display concerns behind this simple interface. Now, before I go further, I just want to throw this in here. Everything I'm saying here is a result of our experiences talking about things that have worked well for us. I don't mean for any of this to be prescriptive. So remember, the goal at the end of the day is to write clean, factored, testable code, not to blindly follow some dogma or other. So for us in our experience, MVP helped us a lot to solve our problems outlined at the start. Not all of them, but a lot of them, and I'll go through other solutions as well. And we found it useful in that we could incrementally apply it to, we didn't have to rewrite everything from scratch. Okay, so with that in mind, I'd like to outline some general guidelines without being prescriptive. I'll be giving examples shortly. So first off, well, the whole point is we don't want any transitive dependency on JSNI in order to run. Otherwise, we have to use GWT test case, so that defeats the purpose. Presenters should maintain full presentation state. That means they don't, well, none of the state is maintained in the view. They don't have to ask the view, hey view, tell me what currently I set you to this value or whatever. They don't have to be recyclable. So this is not really a rule of thumb, it's more just something to point out that in practice, if we're going to be reusing or recycling widgets, we found in our experience that most of the performance speed up is from reusing the DOM, not the presenter, which is a very lightweight object in comparison. So you can keep the logic a lot simpler by not having to do that. I'll talk about that a little bit more. And presenters can delegate to each other, or they can use an event bus. It's up to you. All right. Another point is to avoid the new keyword. I mean, obviously you need to construct objects somewhere, but in your presenters, you should, as much as possible, dependency inject their collaborators so that you can provide different ones for testing. I'm not talking about just their views, but also other presenters and so forth. And I encourage you to try Gin. It's, you probably have heard of it. It's a dependency injection framework, which is juice for GWT. Okay, now onto the juicier bit. View interfaces. This is the most important part. If you design a good view interface, everything else will follow. So they should be satisfied, or satisfiable, I should say, by an obvious, trivial implementations. A default Pojo implementation for testing would, in theory, be machine generatable. In fact, in many cases, it should be possible for a blank implementation to be a valid one. So if you just have all these blank methods, for many of your interfaces, giving that to a presenter, it will still function perfectly correctly and not have any bugs. You can't do that in all cases, but in many cases you can. So what is important, sorry, this is not to say that they can't contain logic, the view implementations. They most certainly can, and I'll give you some interesting examples of this. But what is important is that they are implementable in an obvious, trivial way. The implementation should follow from the interface. This makes testing easier and accurate, and in practice, most real widget implementations of the view interface will in fact lack non-trivial logic. So the second point is that the view interfaces should avoid implying a particular layout or design. They should present an interface relevant to the application logic we want to test. This model is good not just for testing, but for example, would be good for an app that wants to have both desktop browser and mobile browser views, or even for a non-web app version of an application. Finally, for the last point, avoiding state getters simplifies the view contract, because then view implementations aren't required to maintain any state. So that ties in earlier when I said about presenters should maintain full presentation state. I don't mean views can't contain getters, but they shouldn't contain getters for state. I'll give you examples of this. So lack of redundant state avoids potential bugs and requires less code. There can be some exceptions, for example, DOM size querying, but this kind of thing is not state explicitly maintained by the view, and so is not redundant. In any case, it's fairly easy to mock up for tests. All right, in terms of the events that views send, events sent to view listeners should be at the correct semantic level, their own semantic level. They're too low if they correspond directly to browser events, such as key down and key press. And this also pushes cross-browser event pain into our application logic. They're too high if they correspond to application logic itself, resulting in brittle coupling. For example, we didn't create an open image or show slideshow in that image thumbnail example here. We just have a, click. The user did a UI gesture. It's because it's not the image thumbnail's job to care what happens when it's clicked. So, and finally, prefer limiting views to one listener. If you have more than one, that's probably a code smell, as the view is being made to maintain too much. So this is a slight departure from Ray Ryan's talk, where he advocated having methods like has handlers, get button, has click handlers, get button. So where you would get a button from a view and attach handlers, click handlers to it like that. There's nothing wrong with that. I just personally prefer an interface where the implementation can be more blank, and this way the event listening is simpler. So at this point, I'd like to illustrate with a more real example from our own experience, which illustrates many of the main points. Google Wave's Wave Panel UI. Now, I'll just quickly explain a cut-down version of the UI flow for those unfamiliar, so on the same page. Conceptually, you can think of a wave as nested threads. Each thread contains either blip switcher messages or more threads. So this is basically what would be stored in the model, so to speak, something like this. When we want to render it, we want the blips to show up like this, and they're grouped into a thread, as you can see. And note the green bars on the left, which denote read, unread status. A clickable blue widget at the bottom of the blips prompts the user to add a new blip to the end of a thread, like so. And it can show up differently between blips, prompting creation of an indented subthread, like so. like so, with its own blips. And also note how the chrome around the blips differs depending on their place in the UI. For example, whether or not they have a dashed border. Okay, so I think this is interesting enough, and how would we structure this using MVP? Well, here's a subset of the view interfaces taken directly from the code. We have thread view and blip view. They both extend some blank view interface. The thread view provides two covariant creation methods for the addition of new blips and threads within the parent thread. So if you look at them, they're quite reminiscent of a DOM-like insert before method. So you give it the item to insert before, and if it's null, it would insert it at the end, that kind of thing. Notice how there is no need for getters here. The view contract here is, in this particular interface, the view contract is quite straightforward, leaving all the maintenance logic to a presenter. There's no get the nth view out of get the nth child view or anything like that. Because you'd have to actually maintain a collection and potentially provide some kind of non-trivial logic. So the next one, a blip view contains exactly one indicator view. The indicator is that blue thing that you saw. So using UI binder, it is quite natural and efficient to create both in one go because there's just a one-to-one correspondence with them. You just create them all in one go. And so we have a getter here. It's not a state getter. It's just a little covariant getter that returns the indicator view that is the child of that blip. And that's just a getter for a member variable that was constructed by UI binder straight out. Or that's one obvious implementation of it. And finally, a bunch of set and forget methods. So one for showing or hiding the green, red, unread status bar, and another pair for controlling aspects of a presentation that depend on the state and structure of the surrounding thread. So the show divider and hide divider, those are the dash border things, and the logic for that can be quite tricky for when we want to show and hide them because it depends on the positioning of other blips and threads nearby. And so this style of interface frees the view implementation from having to worry about that logic. We can put it all in the presenter, and the view implementation follows trivially from this. So now I'm not going to show you any really complicated presenter logic talking to a view because it won't fit on a slide and the details of such code aren't really important to my point. I will show you an example of some lifecycle code, which is the boring code, but it will give you some idea of how to create views, their presenters, hook them up, and all backed by some abstract data model if you have one. Okay, so just going through it quickly. This method, let's say in our data model, because an event came from the server to tell us to do so, or there was a UI gesture that told us to do so. Either way, our data model has been updated so that we now have a new blip, and we're given blip, and blip is the model object. So, oops. That's better. So we just, from our state, get the view for that current model object. And then we ask the view, which is this is in a thread. This is in a thread presenter. So we get our view, and we call that create before method. So we've got the view for what its next sibling is going to be, or null. We create the new view for this new presenter we're going to make, and then we create it here. And I made a tiny typo. This should be blip. So we have some factory which creates a blip presenter given a view and its model. There's just two things we're passing into here. Now, in reality, a presenter might have many other dependencies, but using a factory, we can curry those all up, and so we don't have to thread dependencies through 7 constructors all the way down. This is just normal dependency injection, so I won't go into that in detail. Okay, and then we return the blip presenter. So then we do all our state stuff, and yeah, so that's just to give you an idea of the life cycle. Okay, now for testing purposes, what kind of view implementations? Let's go into actual implementations now. So testing ones are obviously the simplest. If you use something like Eclipse or an IDE, you can just say, you can generate most of the boilerplate implementation for you. You just say, well, generate all the methods, and if you have a good view interface, that blank implementation, as I mentioned earlier, would probably suffice. But obviously, if you want to record what gets called, you can use some kind of mocking utility, so maybe something like Mockito or EasyMock or JMock, or whatever you prefer. It makes it, with that style of interface, it makes it a lot easier to mock because usually, since we only have these setters, by and large. It's much easier to mock because we don't have to say, when you call this getter, return this thing, which then gives you this other thing, so you can attach listeners to it, and it's, this is quite straightforward. Now, a more real practical example. Obviously, so if we have our widgets that are actually implementing these interfaces, as an efficiency thing, we might want them to be recyclable. So we've had this init reset recycling pattern where you call init when the widget's first going to be used, and you call reset when you want to stop using it for now to perform any cleanup, and then put it back in a pool of widgets for reuse, so we don't keep creating new DOM. This is actually a good performance boost. Now, in the past, when our what is now presenter logic and the display logic were all sort of munged together, the implementation of init and reset were quite tricky and also caused a lot of bugs. However, because presenters are order of magnitude more lightweight than the actual widgets, we can now that we've got these separated, we don't have to reuse our presenters, and we can make all the variables final, and it's just one fewer dimensions to worry about for testing. And in practice, it turns out for the widget implementations now of init and reset, because we have such a dumb contract, it's basically they're either no ops or maybe setting a couple of things to null in the reset method. It's very simple. Yeah. So next slide. Here is a more interesting example. So here's an example where the view implementations are actually quite non-trivial. So for a large scrolling UI, such as the wave panel, where you might have hundreds and hundreds of messages and need to scroll up and down, it's much more efficient to render only the visible widgets. We've had enormous speed improvements by implementing this, taking from maybe 30 seconds to open a massive, massive wave to virtually instant if we already had the data loaded from the server, because we're only rendering the bits we need to render. And it turns out that most of the performance, by far all the performance penalty is all that DOM rendering. So the actual full tree can be made in terms of the presenters quite efficiently and without much cost, but it's the widgets that we need to optimize. So we can treat this kind of thing as a view concern. And doing it this way has some advantages. The presenter code, which so far is concerned only with user interaction logic, can remain clear and uncomplicated. It can remain agnostic as to whether or not we have this pagination feature. We don't have to complicate it with this extra dimension this extra dimension. So, and this is another advantage of having a dumb view contract. So to do this, what we can do is we can have a paging implementation of our view. So let's say we have a foo widget or a blip widget or something. So we have paging foo view is the implementation. The presenter talks to it. I've just put it there just so you can see where it all fits in. And then this implementation delegates to either a Pojo implementation of the view, which is a Pojo, plain old Java object, just has basically nothing in it. It just records what methods get called and just sets when you call a setter, it just sets a variable to remember that. And there's a copy into method to copy all that stuff into a real widget when we actually want to page that view in, when we've decided it's come into view and want to render it for real. And in that case, we will have these delegating like so. Okay, so how does this actually work? So I think this is called the state pattern or something. It's not very complicated, obviously. We just get the current implementation. So for example, for the mark unread method I showed you earlier in the blip view, we get our impl and call mark unread on it. Simple as that. For the Pojo implementation, mark unread would simply record that in a variable. Copy into, given another view, would call mark unread on that other one. And for the widget, obviously, we'd use the actual, set the green thing to display whatever. So as you can see here, though, the paging logic part of the view implementation is actually testable. So all this blue stuff here is all still 100% JUnit testable. It's still only this bit here that's for hard to testing. But since it's the logic in here is still trivial, we're all good, right? So this is an advantage of having a dumb view contract again. Okay, so just a little side point. I've mentioned the word covariant a few times, and I want to emphasize it. So when I say covariance, I don't necessarily mean it in the strictest type system sense of the word. For example, in those create before methods, we accepted a view. We'd obviously have to cast it to a particular widget, in our panel implementation or whatever we're using to be able to insert it before in the list. But the important thing is, what I mean is I'm referring to that the entire runtime view structure, like the whole tree of all our views together, is a closed universe. So that means no presenter code can actually construct view implementations directly. We can't decide what view implementations we're going to use. So this allows different groups of collaborating view implementations to be injected in different specific contexts. For example, we could enable or disable paging by using a different group of view implementations, as simple as that. Yes. Okay, so in summary, there's quite a few things there, but basically, I guess the thing I was mentioning most importantly over and over again is to have a dumb view contract, and everything else pretty much follows from there. View should be in a closed universe, and presenters maintain full presentation state. We don't want any of our presentation state to be in the view wherever we can avoid it. Okay, so that was MVP, but I want to talk only about architecture kind of stuff. Using MVP covers a lot of the problems mentioned at the start, but there are a few more that it doesn't solve for us. So one of the problems mentioned at the beginning was the need for web or browser-specific optimizations. So a couple examples I gave were we're using widgets. That's a sort of web-specific. With that example, MVP, yep, we just put it in our view and we're fine. But if we're doing some kind of JavaScript-related optimization to the actual running of our JavaScript, we run most of our JavaScript in all the logic code, so that's a cross-cutting concern. We can't box that away inside some logic view or something stupid like that. So one example is GWT's hash map and hash set emulation is slower than it needs to be. I think Joel was mentioning something about this in his talk earlier, but this is a result of having to match the JRE interfaces. So for example, bucketing is unnecessary for string or int keys. But just in general, to implement that interface, you need a more sort of heavyweight collection. So one thing we can do is write our own web-optimized collections data structures with their own interfaces. And so that's what we've done. We have, to compare JSO string map, which is a map of string to something, implemented with a JSO, which is a JavaScript native object. I'll talk about that a bit later, versus a hash map. And in this case, we have, for a Chrome, this is just a micro benchmark populating a map. For a small map, it takes this many microseconds for a hash map versus JSO string map. For a large map, and then Safari, and then Firefox. So you can see it's roughly a factor of 2 difference in all cases. IE also has similar results, but the numbers were an order of magnitude larger, so the rest of the graph would look very hard to decipher. But you get the idea. So we have some efficient data structures like string map, string set, number map, int map, identity set, int queue. And let's say you wanted to write your own data structures such as these that implement interfaces designed for efficient JS implementations. And then for unit tests or for server-side code, we actually want to back those implementations by regular java.util-based implementations, so we don't actually have to call JSNI code when we're running on the server or when we're running in a test case. So how do we do this? Okay, well, we could define a collections factory interface and dependency inject it everywhere. That's obviously a bit cumbersome just for collections, right? So, I mean, it's pretty straightforward. In practice, we don't really need to provide fake collections with different logic or anything. So a static constructor method delegating to a singleton factory is fine, and we use gwt.isScript to switch between implementations. Gwt.isScript tells us if we're in compiled JavaScript mode versus JVM mode. So if this will return false if we're in hosted mode or not using in any GWT environment at all. So pretty straightforward. So JSO collection factory would have methods like, well, a collection factory methods like string map, string set, and obviously we just call the JSO version create, etc. For the Java collection factory, we would adapt the hash map just to implement the specific interface. I can go into details about why we have different interfaces, and it's mainly to do with iteration. If we want to have a very efficient data structure, we need to change, some iteration has to change how that works, so we need a different interface, but that's not an important point. Yeah, adapter string set, so on and so forth. So, and then we have a factory, which is if GWT.script is for JSO1, otherwise it's for Java1, and then create that. Okay, very, very straightforward. Okay, now sometimes we don't actually want to depend on GWT at all. I mean, not even have GWT in any import statements. So for example, in shared model code that we want to run on the server. So the solution for now is to use supersource. I'm sure the GWT guys will come up with something pretty nifty in the near future, but for now this works fine. Supersourcing is basically it's like overriding a class path kind of thing. You just say, instead of this implementation of this class, use this other completely different one, and it's the same, you know, package name, same class and everything. We just say, use this other one instead. So obviously that's, you know, copy-paste code sort of duplication. We want to minimize that, so the idiom we use is to have this, just a platform.java, that's a sort of a standard idiom, where we put the platform-specific differences, as it were, inside here. And so it's fairly straightforward. From the collection utils method, where we set up that factory, we just call platform.init collections factory, which will then call back and set the appropriate one. And in the default case, it just uses the regular java.util implementation. But then in the client, we supersource this. So for the code that doesn't do any GWT-specific stuff, we'll get the regular one. And in the client, we supersource it, and then we have the switch here. We still need the switch because for things like hosted mode, it's still nicer to use the Java collections just because they're faster when you're actually running a JVM. You don't have to cross, the instruction point doesn't have to cross the JavaScript boundary continually as you're accessing your collections. Okay, so another thing I'd like to talk about is asynchronous logic. This is sometimes a pretty tricky one. So for example, how would you test this? So you may not know it, but, well, I hope you don't know it, but in GWT test case, you can actually defer the failure or pass status until a timeout has elapsed. So needless to say, this is nasty as it makes tests flaky and take even longer to run. It should only be used when you really need, in some integration text, for some integration test context, like if you're actually talking to a real backend. So I guess the obvious solution is to dependency inject some kind of timer interface, which we can then fake out, and in the tests, we can manually tick the clock synchronously in our test, but the thing using the timer interface will get callbacks and so forth as it normally expected. Okay, so just an example of this. This is basically what we use. We have a schedule method, or overloaded versions of it, where just accept the familiar command and incremental command interfaces. So there are a few flavors of that method just for convenience, but you can notice that the interface here, it's not a subclassing type API like timer. It's more a service where you schedule tasks. So the advantage of this style of interface is that it allows the entire application or part thereof to share a single timer service or have different centralized timer services running at different priorities. It makes it easy to fine-tune the running of background logic, animations, rendering. It's an invaluable testing and debugging feature for a large and complex application. Just a little mention. Oh, actually, I'll mention that later. So, all right, this is a pretty nasty one. Events. So I mentioned at the start, we have a lot of subtle differences between browsers in terms of key down, key press. So in particular, key events are particularly nasty. So I'll give you an example of this. I'll just show you with this little testing harness here. So we know, see in WebKit, if I press and hold, you may notice I get a key down and key press all the time. Whereas in Firefox, when I press and hold, I just get a key press for the repeats. So if we just listen to all key events, we would get duplicates in WebKit. You have to. I'm sure a lot of you would be familiar with this. You need some special logic, but it's not as simple as that. It gets quite complicated in terms of depending on what key it is and so on and so forth. And another annoying difference is that delete and full stop have the same key code, and the way in which you actually detect which one is which also differs between browsers, and there's lots of examples, not just the delete key, so just, it's a bit of a nasty one. So the solution that we have is we defined an interface called signal, just to make it different. It's just basically an event, same kind of interface. And what you do is we create one from a raw event. So we get a raw browser event, we create this signal thing, and then this method will return null if we should just ignore it, which means if, for example, if it was one of those redundant key down or key press events. And then using that, we can then, the interface will provide the difference between things like, it won't just get the key code, we'll know the difference between delete and full stop and so forth. So for example, let's say this is in one of our dumb widgets. I know there's an if statement here, but I wouldn't really call this logic. This is more a declaration of what the events are we're propagating. So if we hit delete, we call listen on delete. If it's an input type event, so a full stop would be an input type event, we call listen on user editing. Now, since this signal thing is a nice little interface, if you want to do more complicated logic, if it belongs in the presenter, you could just make that part of your listener interface and call on signal and just pass that in. So in here, we have all the complicated logic that actually does all the cross-browser event normalization. And so what's our test strategy for this? Well, how would you test this kind of thing and actually, how would you test it when it's such a low-level real browser thing? Well, our strategy is actually to record, again, using this using this tool. We can write a little WebDriver script that goes and presses a bunch of keys, and we can take all this test data and actually record it in a big file, and then that actually runs in milliseconds. We can regression test all our logic. So we can call these methods like, check that left is a navigation thing, check that delete actually gives us a delete, and we don't get redundant events and all that kind of stuff. And for German keyboard layouts, that kind of thing. So we can, this is a bug we had once, and now we have a test for it, and that's not going to be a bug again. So it's a small test that tests all this cross-browser event logic. And yeah, I'll just give you a little demo of that. So here we have an example. If I hit full stop, and if I hit delete, you see it says delete for one and input for the other. And if I press and hold, obviously it's not giving me duplicates. This is a little test on. Now you could also write a WebDriver test to test this directly, like a kind of a WebDriver unit test, which we do as well, because it's good to have lots of tests. Okay, before I go, I'd just like to say all that stuff I've shown, like the signal logic and the JSO collections and the timer service thing. We've actually open sourced that as part of the Wave code. And although I think it really belongs more in GWT, so we'll probably try and move some of that into GWT or as time goes on. So you can go and you don't have to write all that event normalizing logic. It's done. Okay, so, but hopefully it gives you like some ideas of interesting sort of non-standard ways of testing things. So JavaScript object, I'd just like to talk about, single JSO Impl. I don't know who's heard of it, but it's a pretty useful facility. So before I explain that, just to recap what a JavaScript object is. JavaScript object is used as an interface to raw browser JavaScript object. So for example, if you have a DOM object or something from a JavaScript library, all the methods in a JSO subtype must be effectively final. So that means, you can subclass JavaScript objects, but you can't override a specific method. The important point is that given any JSO, and I call a method on it, I know exactly statically which method to call. So they're syntactic sugar for static methods. And they cannot be constructed by Java code because they're this sort of native object things. Okay, so single JSO Impl is I think it's a little known facility in GWT. It's a facility where you can actually have a JavaScript object being implementing an interface. So an interface method may have at most one implementation defined within a JSO subtype. So that means, I mean, you can think of it as at compile time, if the compiler sees this interface and a specific method on it, it still knows statically which one to actually turn it into. Because these are these JSO things, they don't have any of that runtime dynamic dispatch meta information that is associated with with Java objects normally. Okay, so I'd just like to point out it has nothing to do with whether or not the method itself is native and so on. So what we can do then is for example, our string map implementation can be a JSO. So we can have this very efficient map, which is just a pure, raw JavaScript object. There's no wrapper objects or anything. And our put methods are just updating fields on them. Like so for example, this is just a helper that basically sets an exact key value pair on a raw JavaScript object, escaping it via some optimized escaping code, obviously. We can do better than just prefixing it with a colon or whatever. And yeah, so this implements the interface directly. We don't need wrappers. So this is a way to, if you get your JSOs to implement an interface, then you can make your code more testable because you're only dealing with an interface, but it's still just as efficient as if you were using a raw JSO. So that's the important point. Another example, that signal thing, the signal that is created from an event, it's not actually created, it's still the same event object, but we just cross-cast it over to this, and now it implements a nice interface. So I think that's pretty nifty. And then, get key code would be event.as this get key code, for example. And that all compiles down to a property access, right, at runtime. Okay, so one last little thing I'd like to point out, use of test harnesses. It's not really a writing testable code thing, or it kind of helps, but I'd like to advocate the practice of it. If you're writing some UI component, it's good to have a little test app which is just for that. I'm sure a lot of people already do this, but it's good to have a little test app just for that specific component. It's good for fast feature development, all those points I've got here. And it does help a little bit with writing testable code too, because it makes it clear that if you have too many dependencies, it's hard to write such an app. So it helps keep your things isolated and clean. And I'll try and give a demo of one of them. So in the, I showed this earlier, for the, whoops. So for our wave editor, I mean, instead of having to load up the whole client and compile the whole wave client to test, collaborative editing or something, we can just fire this thing up and notice how changes are propagating across to the other side with this, and it's got lots of debugging information. And I'd also like to advocate the use for integration testing of WebDriver. It's a very important part of our test strategy for all the stuff I've said about writing, JUnit small tests and all that. It's still important to have integration tests. And having something like this with lots of places for WebDriver to hook into and set some content or read some information out, which you wouldn't have in your actual application, is quite useful. So anyway, so that's about it. I guess there's lots of things I went through, and I could summarize all of them, but if there's one take-home point, I would say it's this: so avoid non-trivial logic in hard-to-test code. Okay, so we'll start with questions, I guess. Thank you.
Got one Stefan here.
Oh, yes?
Hi. Can you talk a bit more about WebDriver?
About what, sorry?
WebDriver.
Oh, talk a little bit more about WebDriver.
Yeah, especially the Internet Explorer driver as opposed to Firefox driver.
As opposed to Firefox driver, sorry?
Yeah, there is an implementation for Internet Explorer and Firefox.
So,
like in your development for the Wave, do you run it in multiple implementations, or how do you do it on a day-to-day basis?
So I'm not sure I particularly fully understand. So the question was with WebDriver, do we use Firefox driver and IE driver and that kind of thing? Right. Yes, we have. I mean, WebDriver is an interface, and it is implemented by various browser-specific implementations. And then you write a code test which says something like, load up a page, click this button, type this thing, assert that this element has this content, and you write it against that interface, and then that you can run the same test against Firefox, IE, and so forth. So it's actually something I didn't include in my talk because it's not released, so I don't want to make any promises about it. But we've actually internally, I may as well mention it, we've internally implemented a thing we like to call WebDriver, which actually lets us run our WebDriver tests, which are slow and cumbersome, as a JUnit fast test by loading up the GWT application, which if you've written in a testable manner, well, that's one way of doing it, but yeah, load up the GWT application and the WebDriver test in the same JVM, and the implementation of the WebDriver interface just drives the application directly inside the same JVM. So it's actually pretty nifty, but there's a lot more work to be done on that.
Is it open source or is it internal?
It'll probably be released.
Okay.
But yeah, I don't want to make any promises. That's why I didn't actually include it in the talk itself.
Thank you.
Yep.
How does your new architecture, how did that change your ability to do test-driven development? And what does test-driven development actually look like? I know it was in the description of the talk. Do you write your behavior like presenter first, or well, how does test-driven development connect to these changes you've made?
Sure. Yes. Yeah. The talk, I guess the title may have been slightly misleading, but my talk is more about writing testable code. But yes, with test-driven development, I mean, yep, it's definitely good. I think every developer might have their own sort of style. We don't. At our workplace, we don't really particularly enforce that you do one thing or another, but it's very important to have tests. Some people find it hard to write a test first just because they want to play around with the code. They haven't really come up with exactly what the interface is before. So I mean, yes. Is there anything more, like a specific question about that? But we don't have. I was just
hoping for an example of like what a test-driven development process would look like that was enabled by this.
A test-driven development process that would
couldn't otherwise be done. Like, what sort of test how could you do test first with this in a way you couldn't if you had done an MVC instead of MVP?
I think that's the question was how could you write tests first in this way, but in a way that you couldn't with other patterns? I think it's kind of orthogonal. I mean, it's more with these patterns and these ideas, it helps you write different kinds of tests, I guess. So it doesn't help you write a test at a different time. It just helps you write more tests when you write them is sort of a separate thing. In my opinion, I think, yeah.
One of our pain points is managing and making sure that we have a specific tab order of things that need to be done, and I've yet to figure out a good way to have tab order be unit testable. As far as I could tell, Selenium is not able to, it doesn't actually record when you do tabs. It just records the actual actions. Like if you tabbed through an entire Google search page, and then you typed something in, and then you did tab through it, and then you hit enter, it would just record the enter. It wouldn't actually record any of the tabbing. Have you guys come up with any solutions to that?
So the question is, have we come up with any solutions, particularly with respect to tabbing with Selenium tests? So you're saying when you tab from one input field to another, it doesn't behave properly, or it doesn't record it?
More like I need to make sure that when we as we're making all kinds of changes to our code base, we haven't inserted some things in somewhere.
Oh, you want
so
to-
that all of a sudden we don't have a new control somehow hidden, like somebody threw a focus panel someplace that's now grabbing focus.
Okay, so you're asking, how do you make sure the tab order didn't get broken? How do you write a test for maintaining tab order?
Exactly. Yeah.
Okay, that's a good one actually, and I think we did have a test for that, or maybe we haven't done one yet. But I can't see why that would actually be a problem, because you can find out which element has focus on the page, right? So unless there's an actual deficiency in Selenium, maybe try WebDriver, because it's actually WebDriver is the next Selenium. It's the same. It's Selenium 2. It's going to be rechristened and everything. So WebDriver, because it's not JavaScript sitting in the page, it's actually a plugin, so it can do more native kind of driving of the page. So that should really work. And then with WebDriver, you can also call Java, like in your test, you can actually call JavaScript on the page directly. So you can set up little WebDriver hooks in your code. So in your GWT code, for example, native hooks, you just say window.WebDriver test hook, blah, 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 equals some call out to some other method. And then you can return, you can have a test hook that, for example, returns which element is currently has focus, or if a specific element has focus, And then you could just make your test go tab, assert this element has focus, tab, assert this other element has focus, or whatever exact logic you particularly want to test, and that should work. I hope that answers your question.
Yeah, it does. Thank you.
Okay.
I think you may have just answered my question. I'm not familiar with WebDriver, so you're saying that's a replacement for Selenium then?
Yes, it is. The path it's headed is to be Selenium 2. So
Okay.
it's. I'm not sure. It's being actively developed. We use it. It's quite feature complete enough for us to use.
Okay.
But perhaps there's still not 100% feature parity, so that's why it's not Selenium yet. But the approach is it requires more work, obviously, because you have to write a specific implementation for every browser. But it also means that the test is more realistic, because it's not JavaScript simulating clicking buttons. It's actual buttons actually being clicked and text actually being typed, not calling event handlers and putting stuff in the DOM explicitly.
Thanks.
No problem.
Yeah, in one of the other presentations, there was some graphs around like continuous performance measurement, and I was wondering how you guys do that, or like is there a way to run
was that the
speed
talk
tracer?
with Adam Shook?
Yeah.
And yeah, that's also the same team. That's what we do.
Yeah, can you talk about how you do that exactly?
Or how we actually get those graphs.
Yeah.
We have cheap little Windows laptops that reboot themselves automatically every so often, because we don't want the test to sort of degrade over time because of Windows or whatever. And we just fire up a browser with a WebDriver type test, and we perform actions in time to see how long they take. And the graph is fuzzy, but it's noticeable. You'll see, it's like this, fuzzy, and then it drops, and it's fuzzy from there, or it raises up. So that's basically what we do. We just have a bunch of those continually syncing to the tip, building and running. Well, we don't obviously build with the small laptops. The small laptops connect to a server, and we see how fast it takes, how long it takes for things to load, or whatever it is that we're testing.
Where do you
answer
get
your
the
question?
timing information from? Is that from Speed Tracer or how do you?
Oh, I don't think we use Speed Tracer for the automated time. We just actually record the time it takes in the browser or in the test. I'm not sure of the details, but it's basically just that. The question was, how do we actually record the timing? Yes?
I'm curious, is there a way yet to test the UI code in a way where non-graphically, where the unit test startup time takes less than a couple or a few seconds?
Oh, absolutely. The UI code itself, the hard to test.
UI code in a non-graphical test.
So Do you mean not the regular tests that we would have, say, for presenters, but you want to actually test the widget implementations of views?
Right.
Okay. So, well, the idea is by using MVP, if you have a dumb view contract, then your widget implementation is so trivial that literally, if it's set this, your implementation is set this other line of code. I mean, that's something that's quite unlikely to break. And if it's going to break, you're going to notice it immediately when you just load up your app. It's not like a subtle bug that's going to regress later and it's going to be hard to detect. So the whole point is to actually obviate the need for even writing that test in the first place. Now, it's still good to have integration tests that sort of run through and make sure everything hooks up together. And in terms of actually making that run fast, there is a way. And what you can do is, and this is one of the things we're doing for this WebDriver thing I talked about, is you can use a custom, it's a bit of a hack, but you can use a custom class loader to replace anything that runs JSON-I. And for example, you can replace elements with some other different implementation of elements that's in Java, and then it can actually run pretty fast. However, at the end of the day, if you want a real, true test, you're going to need a real, true browser. So it depends on how realistic you want to get. And I would say, if you write your code with MVP in that style, on the scale of non-realistic to fully realistic, it's almost all the way at fully realistic, because the rest of the bit that you haven't tested is quite minimal. And then if you're going to do this effort just to test that one little bit further, and you want it to be fast, and if you wanted it to be fast, you're probably not going to be loading up a real browser. You're going to cut some kind of corner. So it's still not going to be 100% realistic. And I mean, do you really care about that last little bit this much? You may as well just have lots of good, tests on your presenters. Put all your logic in a testable manner, and then have some integration tests that test the whole thing through.
Okay.
Okay. Oh, yes, you have a question? So the widgets, you mean? So the question was, with our coverage reporting, do we tell the coverage reporter to ignore the fact that we're not covering the widget code? We don't currently, but I mean, does it really matter? Yeah. So we do have a lot of GWT test cases, don't get me wrong. We have heaps and heaps of GWT test cases, and also this code does get covered with WebDriver as well. It's hard to get coverage reports for that. We're going to work on finding a way to do that, but one idea would be actually run it against hosted mode or something and get coverage that way, or maybe find some way through the JavaScript to get coverage. But it's not a super high priority. Yes?
I have a question. So if you've got MVP tests and then WebDriver tests, which is what I've got now, I don't actually have very many GWT test cases. Do you think that that's fine, that that WebDriver can basically replace those, or where do you see still using GWT test cases if you've got WebDriver in the picture?
So the question is, I mean, if you've got all these MVP tests, and then, so you in particular don't have any GWT test cases?
Right.
Yeah, so we have all these MVP test cases and then WebDriver to do the integration testing, and there's no GWT test cases at all. I mean, if that's working for you, then great. I mean, you don't have to wait for your GWT test cases to run. GWT test case, I mean, I would see GWT test case as a heavy integration level testing tool similar to WebDriver, not quite as heavy. A GWT test case will probably be faster than a WebDriver test, but I see it as somewhere in between the two. But if you've got, if your app is reliable and you've got good coverage and you're happy with that, and then whatever works, I guess. I wouldn't say no, you must have GWT test case. Okay, time up. Thanks everyone.